basically spent last class pretty much on 1.5 because we were talking about how to solve quadratic equations, and we saw 4 different methods, right? We saw the factoring, square root property, completing the square, and then the last one was, of course, using the quadratic formula. Now what we're getting into is basically building up on that, but we're getting into other types of polynomial equations. And if you even just look at that example 1 here, you will see that's a 3rd degree polynomial, right? So we're getting into higher degree. Now remember, quadratic equations are degree 2, right? So they were just 2nd degree polynomial, but now we're getting into, like I said, higher degrees, and then we'll get into some other types of equations also. So let's take a look at this guy here. Okay, so factoring a higher degree equation, we're talking about zero factor property holds true for any number of factors. We saw the zero factor property last time with quadratic equations, and of course we only had 2 factors when we factored our little quadratic polynomial. Now, if you're talking about something like a 3rd degree polynomial here, technically, the idea is it should break up into 3 factors, and we could still use the zero property where you take each one of them, set it equal to 0, and then, we would find our solution based on that. So they're basically saying a zero factor property can hold for any number of factors. It's not just restricted to 2 factors. If we factor a higher degree polynomial equation, set each factor equal to 0, and then, of course, we'll be solving the resulting equation. Often the easiest method for solving a higher degree polynomial is actually going to be factored. So let's take a look at it. So let's take a look at this example here. This is going to be kind of similar to what you have in the handout. As you can see, this is a 3rd degree polynomial, n to the 3rd power. Let's make this factor. So we are trying to gonna solve this by factoring. Now this is not gonna be the same kind of factoring we did last time with the quadratic equations, because of course, being a 3rd degree polynomial, and you will see there are 4 terms in here. You've got n to the 3rd power minus 9, n to the 2nd power minus n plus 9. So we're going to use what we call as factoring by grouping. So we're going to group 2 numbers, and we kind of did this halfway through the factoring process I was showing you guys last time. So we're going to use some of those same techniques. So start by factoring by grouping. In this case, we're just going to group the first 2 terms and group the last 2 numbers. That's kind of the easiest place to start. So remember, when you're using factoring by grouping, you're looking at, okay, now I have my groups. What's common between my groups? So between our n to the 3rd power and minus 9 n squared, what is going to be common between those 2 terms? N to the 3rd power minus 9 n to the 7th. N is going to be common? How many of them? N squared, right? So the way you work with degrees or exponents is whichever is the smallest number, that's going to be what's common, right? Because we've got 3 n's and we've got 2 n's. So of course, we can pull 2 of them out of those 3. So in the first grouping, n to the 3rd minus 9n squared. Write out our common here. And like I said, we're grouping these 2. So between our first grouping, n squared will be common. Now, n to the 3rd does not have any coefficient on it, so it's understood to be 1. So obviously between 9 and 1, the only thing that's common is 1. So we don't really take any numbers out. Take the n squared out. Out of n to the 3rd, we've taken 2 of them out, which means we're left with 1n. Minus, you've taken the n squared out. So the only thing we're left behind is with that 9, right? And minus 9 is what's left. You will notice we again have a minus sign when we begin our next grouping. So you're going to take that minus sign between the next grouping. Which again, remember, will affect your sign when we move forward. Between n and 9, is there anything common? No. So anytime there's nothing common, we always go for number 1 because 1 multiplies into everything. So you will actually bring 1 outside as your greatest common factor because nothing else was common between those terms. Now you took that negative sign outside right over here, which means that negative n that you had in the original expression will now actually end up becoming positive. And the positive 9 in the original, you are, since again, we're taking that negative out, will end up becoming negative 9 over here. Okay, so anytime you take a negative sign outside, where's my No, this is coming from my laptop. Anyway, when you take this negative sign out, the signs in your parentheses are always going to change. So you can see the negative n ends up becoming positive n. The positive 9 ends up becoming negative 9. Guys, see that. So just keep in mind anytime you're doing that factoring, okay? Alrighty, so let's get this slide here. Again, as I had mentioned last time, if you factor this correctly, both your parentheses should always come out to be the same, and they are, right? Because we ended up with n minus 9 in both of them, so group them together now, they become one term. And then everything else that's on the outside will combine together. So I've got n squared over here, minus 1 over here. So these guys will become the second factor. So n squared minus 1. So again, n minus n combined together into one term. And then everything else that we had on the outside ends up becoming the second parenthesis. So that's where the n squared minus 1 is coming. Figure out where that relates to that promise. Take each of the factors, set them equal to 0. However, we can still factor n squared minus 1 down because it's not in the simplest format. How can we factor n squared minus 1? Does anybody remember difference of squares? So if you have a squared minus b squared, doesn't matter if it's equal to 0 or not. The factors into a plus b, a minus b. This is what we call as difference of squares. Having a vague memory, we talked about this on the first day of class. So how can I convert my n squared minus 1 into a squared minus b squared form? Because I'm only seeing square on the end, right? What happens with the 1? Can I write that as 1 squared? What is 1 times 1? This is the only number where you can actually write it as a square because 1 to any exponent will always say 1, right? I can take 1 to the 10th power. It's basically 1 times 1 times 10 times, and it's still going to be 1. So 1 is one of those few numbers that I can actually do this to. So I can write this guy as n squared minus 1 squared because I know 1 times 1 is still going to be 1. And then using my little factoring here, this will become n plus 1. So technically, if you wanted to, I'm actually going to erase this side. can actually write this guy as n minus nine, and then factor my n squared minus one again into n plus one, n minus one, and then z is equal to zero. So you started out with n to the third power. We ended up with three factors. Okay, so that's kind of the general theory, is depending on the highest exponent on your leading term, that's how many factors you will end up with. All right, then the last part is the zero factor property. Take each one of these guys, set it equal to zero. And that's giving us what values for it. And those of you who are online, you can just put your response in the chat for me, please, so what your n values will be. And you should have three of them, right? Coming from three different parentheses, Samuel?
I don't know.
Tell me that last one again.
9 negative.
Yeah, all right, Salvatore, very nice. So yeah, you're taking each number to the other side, right? So the signs will change. So this guy will end up becoming positive 9. So you end up with n equals positive 9 here. This one will of course subtract. So you equal negative 1. And then the last one, of course, we're adding 1 again. And you end up with positive 1. Daniela, very nice.
Then if you are, instead of separating the negative one, then one plus sign minus one.
If you didn't factor that,
No, yeah. Plus sign minus
like with the same, we did, I actually never tried it, but I think technically it should work. But I've never tried it where you had another number like 9 and then the plus minus 1, but my MATLAB programming sometimes does work. And if it doesn't, if it gives you an error, then just separate. Yeah. So yeah, my MATLAB can be a little picky about certain things. Alrighty, guys. So our solution set in this case would be, let's see, which is our smallest number, negative 1, 1, and then. Alrighty, let's plug these guys in, make sure we get this correct. So yeah, you guys can do that with the plus or minus 1 again. Okay, so question on solving a higher degree polynomial by using factoring. We okay so far? Yeah. Figure this one out. All good, okay, very nice. All right, how would you solve something like number 2? X to the 5th equals 27x. Where would you begin on number 2? Very nice. Yes, you want to bring all the terms on the same side and set it equal to 0. Yeah, Daniela, very nice. Set it equal to 0. So yeah, let's start by subtracting, and it will be easier to actually bring the 27x squared to the left-hand side. Because it's kind of nice to leave your leading coefficient as a positive number, so it helps with the signs and stuff. So leave the x to the 5th on its own side and move the 27x squared to the other side. Now, there's only 2 terms here, right? So you really don't have to do much of grouping because you're obviously going to group those 2 terms together. So when you factor X to the fifth minus 27x squared. What will be your common factor?
X squared.
Alrighty, x squared. So if we bring x squared outside, what are you left with?
3.
Yeah, 5 minus 2, right, on the exponent, so that's gonna be 3, so you'll be left with x to the third, not just 3, okay? X to the third power. From the second term, 27x squared, what's left behind? Just 27, because we take the x squared outside. How are we going to factor x to the third minus 27?
The cube.
So just like we had difference of squares, you actually do have difference of cubes. The formula is gonna be a little bit different. How do I rewrite 27 as something to the third power? What will that look like when you rewrite 27? Very nice, 3 to the third power, yes. Because if you take 3 multiplied into itself 3 times, this will of course give us 9. 9 times 3. So you rewrite that as 3 to the third power. So of course, x squared will stay as it is. We have x to the third, and now we can rewrite 27 as 3 to the third. Does anybody remember what difference of cube formula looks like? Again, I'll just use A and B to write it. Didn't start with A. Yeah.
Square. Or plus,
Yes.
sorry. A times B. Plus.
Very nice. So it will break down into A minus B. A squared plus AB plus B squared. And you know, of course, if you wanted to verify that, well, it's not technically 4, but you get the idea of multiplying it, to check it out, but that should be. All right, so using this format, again, that leading x squared will stay as it is. Now factoring out, this guy will be x minus 3, so that's that A minus B from that first term. So of course, instead of A and B, we have x and 3 as our terms, right? So you'll have x minus 3 on that first one. And then this one will be x squared plus A times B will look like what for our term? 3 times x, yeah. So 3x plus B squared will be 3 squared, which will become. And of course, you still have everything set equal to 0. I may actually need more space than realizing space here. If we did x squared equal to 0, or x minus 3 equal to 0, or x squared plus 3x plus 3. What will x squared equal to 0 give us? Because this is where we would use the square root property, right? Because our x has a square on it. Okay, so if I have x squared equal to 0 and I start using very nice author, x square root. Now remember, normally when we take a square root, we get one positive, one negative root. But since 0 does not take a sign, right? You basically end up with just x equals 0 from that first term. But technically, because you did that square root of plus and minus, this actually means 0 occurs twice. So you actually have 2 roots or 2 solutions which are both 0. Because remember, this is a fifth degree polynomial, so two of those numbers are going to be zero. So that takes care of this guy here. What response do we get from x minus 3 equals 0? What will our answer be? Yeah, really nice. That will be Salvatore, very nice. X equals 3. So that's actually my third solution. Now the other two are going to come from this guy over here, which is the x squared plus 3x plus 9. Can I factor that polynomial? X squared plus 3x plus 9? So when I talk about factoring, I'm talking about this, right? X and x here. What are the factors of 9 that will add up to give us 3? See, that's where you got to think about. That's where, that factoring gets tricky. Because it looks like, oh yeah, I should be able to factor this guy. But when we get down to the math, does it actually work out? So two numbers which multiply to give us 9, but add up to give us positive 3. Now, what are factors of 9? Not a whole lot. 9 times 1, which will either add up to give us 10 or subtract to give us 8. 3 times 3, which add up to give us 6 or subtract to give us 0. So none of those combinations are giving us 3. This cannot be factored. So if it cannot be factored, what else can we use to solve x squared plus 3x plus 9? And this is what we did in 1.5 section, right, last time? Yeah, you can use the quadratic formula, or if you're feeling adventurous, you can use completing the square. Those would be your two options in solving this. So if we did the quadratic formula in space, okay, I guess I'm gonna clear out this side for the quadratic formula. Switch down this one. So remember, quadratic formula is x equals negative b plus or minus square root. You discriminate b squared minus 4ac, and then the whole thing divided by 2a. So what is our a, b, and c coming from the polynomial? So what's the a value, the b value, and the c? So x squared plus 3x plus 9 is our polynomial. Based on that, what is going to be your a, b, and c here? What do you think your a, b, and c is going to be from the polynomial? Very good. Very good. Positive, negative. And C. All right, perfect. So using that, we have negative b, and b happens to be positive 3, so that basically is negative 3. Plus or minus b squared would be 3 squared. Minus 4 times a is 1. C is 9. The whole thing divided by 2 is 0. So clean that up, and that will give you your remaining two solutions for this polynomial here. So what does that little quadratic formula simplify into? Will they be real or imaginary solutions? Imaginary, and that is because the discriminant is coming out to be negative inside the square root. Right? Let me know once you have your answers, guys. in your solution. But are you sure you're comfortable with this one? Yeah. Yeah, very close. The only thing I would suggest is now that we find it is separate by the compromise, you will convert this into anything that works. Plus minus. Because you have to have it in a plus bi and a minus bi, so we need to separate the denominator. Alrighty, guys, let's take a look. So we have -3 on that front, plus or minus. This guy becomes 3 squared is 9 minus 36. So whole thing divided by 2. Plus or minus -27. Then divided by 2. Oh, so minus this. And since we have that -27 inside the radical, remember that's where your imaginary numbers come into play. So that -27 will basically separate into square root of -1. I square root of 27, so square root of -1 becomes I. Square root of 27, what does that simplify into? We can't leave it as square root, right? You have to bring a perfect square out of it. Yeah, so now 3 times 9, square root of 9 comes out nice and clean as 3. Yeah, Daniela, very nice, that is perfect. And then of course, one of the 3 stays inside the radical. So this will actually end up becoming -3 plus or minus, and the way you write it would actually be 3i square root of 3 and the whole thing divided by 2. The only last thing I would ask you guys to fix is, and I don't know if my MATLAB accepts this format or not, you can try that, but normally we need to separate that as -3/2 plus or minus 3i square root of 3/2. So you kind of separate that denominator because we need the real part, which is the -3/2, and we need the imaginary part, which is the 3i square root of 3/2. So you're separating the real and the imaginary because that's how we write complex numbers. So obviously you're still keeping the same denominator, but we're just separating it between the real part. So this is the real part, and then this is the imaginary. So the last answer we're going to come up with, of course, we have x equals 0, which occurs twice, x equals 3, which occurs once, and then we have -3/2 plus or minus 3i square root of 3/2, which is of course 2 different answers, right? Separated by the plus and minus. So there's your 5 total answers for your solution set. Those of you who are on Zoom, Salvatore, Daniela, any questions on this example here? Daniela, you're pretty strong. Okay, so those were working with higher degree polynomials. Now we're getting into how do you solve equations that already have square roots in them, right? One of the things you have to keep in mind when you're working with square roots, and this will actually be true for if you were doing like a 4th degree radical. So that was what we would call as a 4th root, right? So you have the square root, which is a degree 2 radical, cube root, which is 3, 4th root would be the, 4 as your index number, 5th root, and that kind of thing. So all even roots have the same concept. So we're working with square roots here, and what happens is to get rid of the square root, we of course have to use square, right? Because again, they are opposite inverse operations, so the square will cancel out the square root. But what happens is the moment we bring that square into play, you end up with extraneous roots, which means you're actually going to have an extra answer, which will not satisfy the original equation. So you're going to come up with an extra solution by applying that idea of a square. And so if you don't check, because so far we haven't bothered about checking our answers, right? We've said, yeah, it's gonna work, we're good to go, our math works out. Except for these types of equations, you will need to check your answers because one of them is going to be an extra solution that is not going to satisfy the original equation. And that's what we're talking about here, having an extraneous root. So if you raise an equation to an even power, and that's why I was saying this will work for 2nd degree, 4th degree, 6th degree, all of those even powers. It's going to be the same thing. You are going to end up with extraneous roots. So here's your steps on how we work with this. Isolate the radical if there's only one. Separate the radicals on opposite sides if there's more than one. So, if you only have one square root, bring it to one side, move everything else to the other side. If you have multiple square roots, then you need to bring them on opposite sides of your equal to sign. Of course, square both sides, simplify. And then from there, we're basically going to try and see, do we need to separate more radicals? Do we need to bring them more on one side, everything else on the other side, and kind of continue that process? And this is the last one, check your answer. You really, really need to check your answers because like I said, you are going to end up with those extraneous roots. And if you don't check and you put both or 3 or 4 of them as your solutions, it's going to count it as wrong. So here are some examples in your handout. So this one, you will see there's only one radical term here. So, of course, here we take the 12 to the other side and simplify. Or you can have something like this where I have 2 terms with radical signs on them. And this is where we're saying separate them, one on one side, put the other on the other side. Okay, so let's see what we can find in your home. All right, so let's start with this guy. Now this one, of course, we can see only has one radical on the left-hand side. And then the x minus 4 is already on the other side, so we don't really need to isolate them. It's already isolated for us. So let's break it down. So we already have square root of x minus 2 on one side. We have x minus 4 on the other. So your step 1, since we don't have to clean this up, is we can actually start by squaring both sides of our equation. Okay. On the left-hand side, of course, the square and square root will cancel each other out. That's how we get rid of our square root symbol. And we're only left with x minus 2 on the left. We will need to use FOIL on the right-hand side. So this is going to be x minus 4 to the 2nd power. Do not give me x squared minus 16. I will whoop your butt. This is FOIL. That means you're writing this out as x minus 4 times x minus 4, right? You repeat that, and then you do your little first, outer, inner, last calculation. So that will end up giving us what when we multiply this guy?
X squared minus 8x plus 16.
Very good, yeah. So that ends up giving us x times x, x squared. X times negative 4 is negative 4x. Negative 4 times x will also be negative 4x. And then, of course, negative times negative is positive. 4 times 4 is 16. combine the two middle terms, you end up with x squared minus 8x plus 16. So please, please be very careful when you're doing this, because 7 out of 10 times, I'm not even kidding, people will write that as x squared minus 16. And of course, since you missed that whole middle term, your sign got messed up. As you can imagine, that math is just not going to work out. So you just really have to be extremely careful with these binomial terms that are completely squared. Alrighty, so that will be our right-hand side. Let's bring it back to the example here. So we've got x squared minus 8x plus 16. And at this point, you're just combining like terms that you can, and then you will see you'll actually end up with a quadratic formula. So we want to get 0 on one side, which means I'll go ahead and subtract x, which will of course go with my middle term. We're going to add the 2, which would go with our constant term. So combine those like terms. And what will our final quadratic polynomial look like once we combine these things on the right hand side?
X squared
Mhm.
minus, and that's plus 18.
Yeah, very nice.
What is this? Yeah.
Your x squared will end up becoming negative, so then you have to either multiply the entire equation or divide the entire equation by negative. So either multiply or divide, because if you move everything else to the other side, it would end up becoming negative x squared. What is it, plus 9
Minus 18.
minus. So since we have that negative here, factoring will become hard unless you're using quadratic formula, which would get by if you did. But with every other method, it would make you confusing if you keep that negative on the list. So like I said, if that happens, either multiply or divide your entire equation by -1, and that would go back to
Just move to.
or move it to the other side, which is the same thing. Yeah. All right, very good. Good question. Alrighty, guys. So can we factor?
Yes.
Can you tell me what it will factor into? Daniela, very nice.
X minus 6 times x minus 3.
Alrighty, so negative times negative gives us positive. 6 3s are 18. -6 added to -3 gives us -5. Very nice, Martha. So luckily that guy factored, right? If he didn't factor, you could then go back to quadratic formula. All right, so what are our two solutions coming up right now as it is? Yeah, +6, +3, right? Now, this is where we need to check for that extra solution, the extremist root. So let's check, I guess we'll start with x equals 6. And then we'll come back. So going back to our original equation. We have x minus 2, so of course if I'm using 6 as my x value, that will become 6 minus 2 inside my square root equals x minus 4, which will again become 6 minus 4. So the idea is, can my left-hand side match my right-hand side? So on the left-hand side where you have the square root of 6 minus 2, what will that guy simplify into? Yeah. 6 minus 2 gives us 4, and then you take square root of 4, which gives you 2. Now remember, guys, the square root was already there, so that's why we didn't do the plus or minus in front of the square root, because we didn't bring it into the scene. He was already there. What do I get on the right-hand side? So my left matches the right. This is what we call as a true statement, because the left-hand side is the same as the right, which means 6 is part of our solution set. So he's good to go. Now we need to do the same thing with 3. So same thing. Square root of x minus 2, which will in this case now become 3 minus 2, equals on the right hand side is x minus 4, which will be 3 minus 4. So what will this end up giving us? The 3 minus 2 on the left hand side is of course 1. What is square root of 1? Again, he's one of those happy numbers. Right hand side, 3 minus 4. -1. This is where you can see we're getting a false statement because my left hand side does not match my right, which means x equals 3 is that extra solution which does not satisfy our original equation. So you actually only have one number that works in this case, and that is 6. So do you guys see why that extra step of checking is so important in these types of questions? Because you are going to end up with that extra solution. And if you didn't check it and we put both of them, then, of course, we're gonna get that unhappy message from my math lab saying you did something wrong, fix it. Did you guys online have any questions on this example? Daniela, so, no, we're good? What about you guys here?
For the square root. Where did the -2?
Where the negative-
Yeah, because you did 6 minus 2. Yeah, need to check.
Oh, because you already have the -2 in the original, right? Because we're just using this guy to do the check. Yeah? All right, anybody else have questions on this one? Hoping I had included one of these. So this one you can see is where we do have 2 different square roots within that same problem, right? So this one's gonna be a little bit different on how we solve it. Kind of afraid to try. Let's see, draw board. Because if it takes us too much processing, then my tablet doesn't like if I have too many applications open. So I'm gonna try draw board, but sometimes takes less processing. We can solve it on this because that guy will need a little bit of space for us to work. Square root of x plus 6 plus square root of x minus 3. So this is where they talk about isolating the 2 radicals. So we do need to take one of these radicals and move it to the right hand side. Honestly, it doesn't matter which one you move. Since this guy says plus over here, I'm just gonna use him and take him. Negative. Let's cancel it out from the right hand side. And you are left with square root of x plus 6 on one side. And I'm gonna leave it as 9 minus square root of x minus 3.
So if you switch to this, the negative instead of square root won't, get affected.
No, because, think of this as what if this was a parentheses, right? None of that is getting affected, it's just this positive sign on the outside, which became a negative. So the inside of the square root does not get affected. Because the only time that will happen is after I get rid of the square root, clean it up, and then I can, move the 3 by adding it to the other side. So right now, we're keeping it as it is, just the plus in the front became a minus. So this is now the first beginning step. We will start by squaring both sides. You guys want to make sure you have enough space because like I said, this one does take a little bit of time. All right, so we're going to take a square on both sides of our equation. Any place where you don't understand me, stop me right there because it's easier if you stop me then and there instead of us coming back to it. So on the left-hand side where we took the square and the square root cancel out. We're left with just x plus 6 on the left. The right, we will need to do a FOIL again. Okay, because I basically have 2 terms with the whole thing taken a square of. All right, so let's talk about how to take the FOIL on that right hand side. So we have 9 minus square root of x minus 3. And we have a whole square. All right, so that is where you are writing it out as 9 minus square root of x minus 3 multiplied into itself twice. That's what that means on the right hand side. So technically we are still doing FOIL here. So you're going to take the first term multiplied into itself, then the outer terms, the inner terms, and then the last. So you're still following that same process here. So the first terms will be positive 9 times positive 9. So 9 times 9 is 81. Now we are doing 9 multiplied into negative square root of x minus 3. So that's those outer terms. So you have a minus sign on that square root, so minus, and then you're multiplying 9 with the square root of x minus 3. It's kind of like if you had just 9 times x, but instead now that is that whole square root of x minus 3 that you're multiplying with. Same thing's happening on the inner terms because I'm still taking negative square root of x minus 3 and I'm multiplying that with 9, so that repeats just like we would expect it to. So that's that third term, and then the last is where we're multiplying negative square root of x minus 3 with negative square root of x minus 3. So negative times negative will become positive, and then we're multiplying the same number, square root of x minus 3 into itself. So that will become to the second power. So basically, we did, oh, this is before continuing. So basically you took 9 times 9, got 81. Then we took 9 times square root of negative x minus 3, which gave us that second term, negative 9 times square root of x minus 3. My third term will be the same thing, because obviously those terms are the same. And then the last one is where you're multiplying negative times negative square root of x minus 3 times square root of x minus 3. And here, the square root will cancel out the square. Only in the last term though, not in that middle. So let's see. Square root and square will cancel out. Of course, we can combine these guys together. So 81 will stay as it is. What is negative 9 added to negative 9? Negative 18, right? And that square root of x minus 3 actually stays the same because nothing happened to it. It's just the 9's combined. And then at the end, square and square root canceled out, leaving us with x minus 3. So that again tells us we can actually combine the two constant terms together. 81 minus 2. Minus 18 square root of x minus 3. Yeah. The last term? So over here, because you're multiplying the same exact term, right? It's kind of like. So it's actually what is happening, and let me get a. So what's happening is the x minus 3 in the square root is basically acting like a variable right now. It's not changing. So it's the same thing if you had minus 9x minus 9x, right? We would just combine the numbers in the front, right? So we would say minus 9 is negative 18 and the x would stay as it is. That's the same exact thing we're doing right now with square root of x minus 3, because till those numbers are inside the square root, we can't touch them till we get rid of the square root. And that's gonna be coming down the line. We're not quite there. Yeah? Okay, anybody else question on this little part here with the FOIL? What about you guys online? Let me know if you have a question. I'm not seeing anything show up in the chat. All right, so we do need to take this guy back to the front. So let's see, we had 78 minus 18. Let's go back to which page? I lost everything that I had written, so please tell me what did we have on that page? 78.
Minus 18.
So now what can we combine between the left and the right hand sides?
Yes.
The x. So now again, we're actually back at the stage, guys, where we need to isolate that remaining square root term. So the idea is get the square root on one side and everything else to the other side. So we need to get that square root of x minus 3 by itself. So I would probably say move everything else to the left hand side. You know, leave him on the right and move everything else on the left. So I'm going to start by subtracting. Subtract this x. Move it in here. And then I will also subtract the 78 and then for now, yeah, just those two. What will that end up giving us? On the left-hand side when you clean it up?
72.
Because the x cancels out, yeah?
Yep,
No? X minus x?
72.
What's the sign on that? Negative, yes, be very careful with those signs. I know this thing. So positive 6, negative 78 cleans up into negative 72. I know, again, it's kind of messy, but what are we left with on the right-hand side after we move that 78 and the x? What's left on the right-hand side? Negative 18. times the square root of x minus. Okay, so we still need to isolate the square root. So what do we do next? Perfect, divide by -18. I'm probably gonna regret writing that big. But after the little mess I had, I'm. 72 divided by 18, well, of course, two negatives become positive. 4. I'm trusting your math on that. Can somebody else verify? I don't really trust. Sorry. Alrighty, we're finally there, guys. Last part. Now that we have finally isolated the last square root, we're there. So we're kind of going back to where we started. Now that we just have that one square root term left, of course, square both sides, and then you'll get that final result we're hoping for. So square, on the right, the square root and square cancel each other out, leaving us with x minus 3. Left-hand side. There it is. All right, perfect. 16. What's my x? Add 2. So just because we got one answer, does that by default mean that is the answer? No, because again, we did introduce that square, even though we, went through a big long process. We still need to check this. So let's check our answer. All right, so we have x plus 6 plus x minus 2. What was it? And it was a plus sign between the two radicals, yes. Okay. All right, so that will become, of course, 19 plus 6 in that first one, plus 19 minus 3 in the second one. That's 9. All right, Daniela, let's see if I can come to that conclusion. 19 plus 6? 25, and what is square root of 25? 5. All right, so that cleans up. 19 minus 3. 16 square root of 16 is 4. 5 plus 4. Alrighty, so yeah, you can see this guy indeed gives us a true statement. And when you have a true statement, we have a solution. So yeah, x equals 19 is going to be our solution. Okay. Just be patient with this one. I mean, as you can see, it does take a little bit of cleaning up and getting down to that final answer. Just keep in mind, obviously in this example, the solution worked out. But if we hadn't gotten that true statement, 9 equals 9 when we checked, we would have basically ended up saying there's no solution to this. I don't know, blocker or something, a pop-up blocker. Have you tried exiting out of the program and coming back in? I'm not sure why it's saying it's not able to recognize that. Unless Pearson is doing something. Now, Pearson has a knack for doing things at the wrong time. Which let's hope does not happen on the day of birth. So that was our square root. The next one. So we're technically still working with roots, even though we're talking about them as rational exponents. But when we're working with rational exponents, we're basically talking about different roots with different index values. So this could be the fifth root, you know, the fourth root, seventh root, whatever that number might be. So let's take a look at what these guys end up looking. So first of all, you can see the format we're talking about is this x to the power of m divided by n equals k, and that's this what we call as rational exponents, because your exponent is being written as a fraction. Okay, so that's what a rational number is, because a rational number is anything that can be written in the form of a divided by, right? So when your exponent is in that format, we call it a rational exponent. So when you write it as x to the power of m divided by n, it's actually the same thing as writing it as the n root of x, because x is our base, to the power of n. That's how you rewrite a term with a rational exponent. So the denominator of that exponent actually becomes the root, the radical, and the numerator of the exponent is actually your exponent, you know, the power, the degree, whatever you want to call it. Now you can write it as x to the m on the inside, or I can also write this as nth power of x, and I can put that exponent m outside also. So you don't have to have it inside the radical, you can put it outside the radical also. And it just depends on which would work better, right? Is it better to simplify with the m on the inside, or is it better to first do the radical and then raise it to that exponent? So the way you solve these type of equations is, you know, of course, we need to get rid of that exponent before I can get x by itself and then find my solution. So what you do is you invert that exponent and you raise both sides of your equation by that reciprocal of n over m. So if the original was m divided by n, you flip it over and it becomes n divided by n, right? Take the reciprocal. Okay, so start by taking the reciprocal of your power, n to the power n divided by m. So we're basically saying, again, remember there are two real even roots for any positive real number, and there's exactly one real odd root. And that will actually depend on what number is on your denominator, because that will decide what the root of your expression is. So if you have an even root, so that would be, again, square root, fourth root, sixth root, you are going to come up with two real solutions. If you have an odd root, like the cube root, fifth root, seventh root, you know, any odd number, then you come up with one real solution. So that's kind of what that number two is saying. If your m value is even and the k value is going to be a positive number, so m value being even is, of course, my numerator. K value is the number on the right-hand side. If that is 0, you are actually gonna come up with one positive, one negative solution. If M is even, but your K value is going to be less than 0, and we saw this with the square root property, you're not gonna get a real solution, you're gonna get an imaginary solution. I don't know why they don't just say that in your textbook, which is kind of annoying, because if it's not a real solution, it's gonna be imaginary. Unless, of course, we have no solution. And then the last one is if the M value, that number M is odd, you will only end up with one solution. Okay? So let's put this theory to the test. And we'll use this guy here from my math lab. So we start out. We have x to the power of 2/3 equals 2. We will take both sides of our equation. And remember, 2/3 is an exponent, so when you take its reciprocal, you still have to put it in the exponent. So that 2/3 will become 3/2. But it still goes in the exponent, okay? On the left-hand side, you are basically, and this would help, if you guys have not reviewed rules for exponents in a while, this may not be a bad place to review it, because I basically have one base with two exponents on it, right? I've got x as my base, and then I've got that to the power of 2/3, and then we just raised it to the power of 3/2. So the rule for exponents is if you have one base with two exponents, you multiply it. So that's the same thing that's happening here. The 2/3 is getting multiplied by 3/2. What will that clean up into when I try to multiply 2/3 with 3/2? Yeah, because you either multiply them and reduce your fraction, or I would say, hey, the 2 cancels out, the 3 cancels out, I get 1 as my answer. So this is how you get that x to be cleaned up, basically, right? Get rid of the exponent and get x by itself. So essentially, these guys just cancel each other out, leaving us behind with that nice and clean x, and then we'll simplify the right-hand side. So the right-hand side is 2 raised to the power of 3/2. You will see on the denominator of that fraction is the 2, so that's your square root. It's square root of 2, and that 3 is the exponent on 2. Okay, so the number on the denominator tells you what radical you have. The 2 on the denominator tells me I have a square root, and then you're basically left with 2 to the 3rd power, and then you clean that. What is 2 to the 3rd power? Yeah, very nice. Then of course I can clean out which technical letter is that right here. It's 2 times 4. Square root of 4 is 2. The right-hand side is just about cleaning up and simplifying your radical. Salvatore, Daniela, question on this guy? And I know I asked you if you have a question, but a lot of times till you actually start practicing yourself, sometimes the questions may not come up. 1 times. No, because you are raising it, right? It's an exponent. You're not multiplying the base with the exponent. Thank you. I'm glad you asked. I need a square. Oh, I know what I did. And I think I do this every single time. Before I tell you what I did, does anybody recognize what I did? This was what they told us in Yeah, it does clean up, Salvatore into 2 square root of 2, but there's something I'm missing. And that comes back to this guy. Remember when they told us if you have an even number, which our m value was 2, and if your k is positive, which my right-hand side was positive, you are going to end up with plus or minus. Technically, we have taken a square root, so we have to introduce a plus or minus.
So that's
The answer is the same, but we need to have both positive and negative. So none of the math is gonna clear up, but right over here. Plus or minus 2. Just that little detail you gotta be careful about. So again, just to recap, because we had that 2 as the numerator value, but when we took the reciprocal, the 2 goes on the bottom, which means we did introduce a square root, and because we're introducing a square root, we have to introduce the plus or minus. This would be the same thing if that number was a 4, 6, 10, 8, any of those even bring the plus or minus. When we're talking about equations of the quadratic type, we're not talking about quadratic equations. What we are saying is you can take an equation and rewrite it to look like a quadratic equation so that we can use any of those 4 techniques that we learned in section 1.5, factoring, square root property, completing the square, or just quadratic formula. So in this guy, you will see we're starting out with x to the 4th power minus 9x squared plus 20 equals 0. Obviously, this is not in the quadratic form, but I can, like I said, rewrite it and then use one of those techniques to solve it. Same thing with number 7, because I have something to the 2nd power, and that same something is in my middle term. So again, I can actually just write this as, maybe something like u squared minus 8u plus 12, and then I can use techniques of quadratic solving to simplify this, and then come back and clean up all the other things. So a lot of times you will see they will talk about u substitution, because we're going to replace the original variable by using the variable u. Just you don't get confused between I had x the first time, but why am I using x again? So that's why they sometimes call it u substitution. So let's take a look at an example here, and you will see they kind of talk about if you can rewrite it in this format of a u squared plus bu plus c equals 0, then we can use those techniques to solve this guy. The first thing when you're starting out with these types of examples is make sure those terms match. So this guy, x squared minus 6x, has to be the same for that first term and middle. So x squared minus 6x, x squared minus 6x, they match. Now we can do the u substitution. Go ahead.
what if they don't?
Then this method would not work. And then you would probably need to go back to the technique we learned with the higher degree, like, the x to the 5th problem that we had done, or the x to the 3rd we had done, then we would use one of those factoring techniques. Alrighty, so I'm actually going to take that term x squared minus 6x, and I'm going to replace that with u. So I'm going to define my u as x squared minus 6x. So then that means this guy here will be replaced by u, and this guy here will be replaced by u. Just the x squared minus 6x, right? Not the exponent. So this guy is now getting replaced with u, but remember you still have that square term on that, so it will become u squared. Then in the middle, I had minus 22, again, the parentheses gets replaced by u. And then we had the minus 135. Now we can, yeah, use, because now it looks like a quadratic formula, right? I just have some variable to the second power, minus 22u, minus 135. Let's see if factoring will work. I know we're kind of dealing with 135, which could give us multiple different options. Does anybody know what would be a good place to start? What numbers would multiply to give us 135? I mean, it's ending in a 5. So what numbers can we try? As long as it, gives us a negative 22 when we add this.
27.5.
Will that add up to give us negative 22? So 27 times 5 will give us 135. What should the signs look like? Because we know our product has to be negative, right? When we multiply those two numbers. So what kind of signs should I have on 27 and 5? Because one of them will be positive, one of them will be negative. Which guy do you think would do better by being a 5 or the 2? Yeah, since we need the two numbers to add up to negative 22, you want the larger number to be negative. So that would be negative 22, positive 5. And that should work out. So this will be it really doesn't matter. One of them would be negative 27, the other one would be positive 5. Negative 27 multiplied by 5 is negative 35. So obviously that works out. Adding negative 27 with positive 5 will of course give us negative 22. Alrighty, take each one of them with your zero factor property, set it equal to 0. Which will end up giving us positive 27. Now, is this the solution to the original problem? No, because remember now we need to go back and put what u was originally, which we had it right here. So u was x squared minus 6x, and now you need to bring that guy back and then we'll solve it one more time. But what the u substitution does is it's already broken it halfway for you, and now we're just kind of finishing up the last part. So go back, bring in your x squared minus 6x equals 27 for this guy. X squared minus 6x equals negative 5 for this guy. You need to actually bring the constant terms back to the left-hand side. It should become x squared minus 6x minus 27, set it equal to 0. This is what? Plus 5. X squared. I would again say try factoring for each of them. So you should get 2 answers from the x squared minus 6x minus 27 and 2 answers from x squared minus 6x plus 5. So each one of them will give you 2 answers, because remember my original polynomial is x squared to the second power. So that's actually an x to the 4th polynomial that we're working with. So we should have 4 solutions to this. So I'm going to give you a second to try and simplify those last 2 terms. X squared minus 6x minus 27. The key factoring should work on both of them. But you of course have the option of using quadratic formula if you think that might work faster for you. Go ahead. Since this guy is negative 27, you have to have opposite signs. This guy's, you know. Yeah, that works. That should give you the four things. It should multiply the previous one. And if the add does not give you numbers are ongoing. Yeah, because you are bringing in negative 27 over here and you already have x squared minus 6, so you have that. Now, when you factor in, you have to think about what two numbers will multiply to give you negative 27, but add up to give you. How are we looking at this? Yes. I don't have my glasses on, my student, assuming you have the right. Awesome. How are we doing with it? And did the restarting just fix it? That means there's only one negative number that's yeah. Alrighty, those of you online, what did you guys come up with as your 4 solutions? Do you have something? Alright, guys, let's see if we can open this up. Add exponent 6x minus 27, which will be x. If it does that minus 9, it will give us negative 27, and then gives us negative 6. Perfect. We will end up giving us x equals positive 9, x equals negative 300. Five. The good thing about 5 is there's only 2 numbers that work, so it's gonna be 5 and 1. Since you have a positive 5, but the middle term is negative, that actually tells you both your factors have to be negative. Which will, of course, once you set them equal to 0, end up giving you positive 5 and positive 1. The other thing I want to mention is on the left-hand side where you did have the negative 27, anytime your constant term is going to be negative, and it really doesn't matter what the middle term is. If that constant term, the 27, that number comes out to be negative, you are always going to have opposite signs in your factoring. So that told us one of these had to be negative, one of them had to be positive, And then the -6 kind of tells you the larger number should be the negative in this example. So that's why we had the -9 and the +3, and then of course, get your final results. So yeah, those are our 4 solutions. So our solution set would be -3, 1, 5, and 9 with all the plus. Let's check these answers. Which would be -3, 1, 5. Questions on this example, please? So using the quadratic solving methods on something which can be rewritten as a quadratic equation. And again, you've got a bunch of different examples in your handout that you guys can kind of look through if you wanted, just to practice a little bit more. We kind of did something similar to number 7, but like I said, you have a little bit of an easier example if you wanted to look through that. I probably won't spend time on number 8. You do have that in your video lecture, but the one thing I would tell you is when you're doing the U substitution, remember we want to keep that x squared because we want to convert this into, looking like a quadratic equation. So when you actually rewrite this for the U substitution, your middle term will actually be your guide in this case. And this is true for all examples. So in that first one, you can see my middle term has an x squared on it. So when you do the U substitution, your U will be equal to x squared. In number 7, where my middle term had the x squared plus x, and you can see this is just x squared plus x to the second power, my U substitution would be x squared plus x. In number 8, let your middle term guide you again. So x to the 1/3 power is actually going to be your U substitution. So this is where we would set this up as x to the 1/3 for my U. So then this guy would become U to the second power because you've taken this and you've rewritten it as x squared times x to the 1/3. So you've actually taken that, sorry, not times. You're separating the 2 from the 1/3. So you're, taking that 2 and using that for your U substitution. The middle term would just become minus U, minus 6, and now you can solve it. So let that middle term guide you for what your U value is going to be, what that U substitution is going to be. Okay, so the last thing I want to talk about is, and we kind of did this again at the beginning of chapter 1, is how do you solve an absolute value equation? And you can again see there's 2 different forms for an absolute value equation. This is actually going to be very similar to what we had done earlier. Tell me again, what is absolute value? Distance from 0. So that means I can be going to the right-hand side of my number line, or I can be going to the left-hand side of my number line to find that distance. So when you set up your absolute value equations, you have to take into consideration, am I going to the positive side, or am I going to the negative side of my number? That's it. That's your setup. So always have 1 positive, 1 negative when you're setting up your absolute value. Even if I didn't have the absolute value symbol on the right-hand side, I would still have to set it up. Because again, am I going on the positive side of the number line to find that distance, or am I going on the negative side to find that distance? Bring your like terms together. So I'm thinking maybe I want to subtract the x here. And move the 3 to the other side since I moved the x. Get rid of your x on the left, get rid of the 3 on the right, so that we're separating the x from the constant term. 2x minus x will give us what? Just x. 9 minus 3, of course, is 6, so that all looks simple enough. What do we end up doing for x plus 9 equals negative parentheses 2x plus 3? What happens with that negative sign? Very nice. You have to distribute that negative sign inside your parentheses. So that will end up making it negative 2x minus 3. Since it's negative 2x, I guess I'm gonna move him. Add the 2x on both sides. And again, guys, my goal is to make my unknown value positive. So that kind of is what my decision is based on. So I wanted to get a positive x, so that's why it's easier for me to add the 2x. But if you wanted to subtract the x, you will still get to the same answer. So add the 2x on both sides. Which means if I brought the 2x here, I need to subtract the 9 to the 2x. 9 cancels here, 2x cancels here. So 2x plus x. Very nice, equals something. So what's our x value then? All right, very nice, Daniela. I just saw your answer. Divide both sides by 3. What was that x again? So basically, this tells you can go on either side of your number line and you will still find the solution which will satisfy our equation. So our solution set will be negative 4. Questions on this guy over here?
Why would that absolute value, x plus 9 on the left, never come out as a negative x minus 9?
I mean, technically, I guess we could have, but then in that case, what you would have done is not change the sign on the right-hand side. So you could have done, which again, that first breakup would still be the same. What did I? So you could do this as x plus 9 equals, 2x plus 3. So that will stay the same because they're both positive. And then for the second one, if you wanted to leave this guy as it is, then put the negative on this side.
So if we have one of those, only one side needs to come out.
Yeah, you don't need to change that one side to a negative. Because they could have put the 2x on the left-hand side and they could have put the x plus 9 on the right. I mean, that's just the same. But as long as you're taking into account one side has to be negative, one side has to be positive. Alrighty, so my ambition did not work out. We only got 1.6 done today. Karma, right? You guys are in luck. We're gonna finish 1.7 on Thursday and then your exam on next Tuesday. A week from today. Yeah. All right, guys, have a wonderful day. Be careful, and I will see you on Thursday. Did you guys online have any questions? Daniela, Salvatore? Are you there? Give me a second. I am aiming to do it right now, so I can. I mean, in time.
Thank you.